Hello, everyone, and welcome back to the Math Puzzle Crash Course. Their fledgling little YouTube channel here. I've got a simple order of operations puzzle for you. This one is similar to some of the others, just mixing addition and multiplication. So let's start right in. It's 6 plus 7 times 8 equals what? All right, and real briefly, as I've done before, order of operations convention is a four-step process. You have parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. So if there's no parentheses or exponents, you start with multiplication or division and work your way through. So following the order of operations, we see we have no parentheses, we have no exponents. We do have multiplication. We don't have any division. So this one's pretty easy. So we have 7 times 8 equals 56. Then we move to addition. We don't have any subtraction, so we do have some addition. So we have 6 plus 56 equals 62. There is another way to solve the problem. You can just move the multiplication to the beginning. You're still solving it first. It doesn't change the outcome at all, moving it that way. So in this case, we could have written it 7 times 8 plus 6 equals what? Well, you do the 7 times 8, you do the multiplication again, you'll get 56. 56 plus 6 is 62. So the correct answer to the puzzle is 62. There is another method, and I do like to show this one just to kind of drive home the idea that multiplication is nothing but repeated addition. So here I've taken 6 plus 7 times 8, and I've rewritten the 7 times 8 by adding 7 eighths. It's the same thing. It's much easier to write 7 times 8 than it would be to write 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. It actually hurts saying that. So, yeah, much easier to say and write 7 times 8. I did put parentheses around the 7 eighths. I only did that for visual clarity. It doesn't change anything in the problem. It doesn't change the order at all because all I have in that bottom line is addition. So putting parentheses around addition when you only have addition doesn't change anything. Addition is addition is addition. So if you add that all up, if you add the 6 and then you add the 7 eighths, you're going to get the answer of 62 again. So just to follow up here, as I already mentioned, multiplication is just repeated addition. Division is multiplication by a reciprocal. Then exponents, which we didn't have here, but if you did have exponents, think of them as repeated multiplication. So in other words, when you have exponents, you might have 5 to the third power. All that means is you're multiplying 5 by itself 3 times, basically. 5 times 5 would be the same thing as 5 to the third power. So it's much easier to write it using exponents. So exponents are going to have higher priority than multiplication or division because of that. Then your parentheses are just grouping symbols that tell us to resolve any operations inside of the parentheses before you would solve anything outside of the parentheses. So if you don't have any parentheses, you still follow the order of operations. You would look at your exponents. If you don't have any, then you say, okay, do I have any multiplication or division? If you do, then you would do those operations first. Then you move on to your addition and subtraction. So it's pretty simple. Um, Basically, I want to say too, the order of operations convention is not arbitrary and it makes sense. So hopefully this description's been helpful and you can use this on some other problems. The Math Puzzle Crash Course is on YouTube and Facebook. Appreciate any likes, any shares, Any subscriptions to help out with the channel is great. Trying to do this to help people understand some basic concepts in mathematics. A lot of the focus so far has been on some, early elementary school mathematics. I think order of operations might typically be like fourth grade elementary school, something somewhere in that range. So just trying to cover some of the basic concepts and then build from there. So I hope this has been helpful and have a great day.